We recently discussed permutations. Permutations where we have a number of objects. We've got a certain number of items that can be selected, or maybe to be consistent, we have a sample space. And there's different ways that those permutations can come about, but the order is important if it's a permutation. With a combination, it's very similar. We have a certain number of items to choose from. We're going to make a certain number of choices, but the order in which those choices are made are not important. And we have a similar formula for combinations, but it does have a difference to it. And one of those is we got n factorial over n minus r factorial. That's with our permutations. But with our combination, the denominator here, n minus r factorial, is also multiplied by r factorial. N again meaning the total number of objects, for the r being the number that are going to be chosen. So let's look at what we have here. A group of 4 students is selecting corsages and boutonnieres to wear to the spring dance. They can choose from 4 roses, 6 carnations, and 8 tulips. If all the flowers are different, in how many ways can 4 flowers be chosen? There's a little information in here that you might think is important that's not. This first sentence here about the 4 students, that doesn't really factor into what we're calculating. What we're focusing on are the objects, in this case, the flowers. Now, how many total flowers do we have? Well, we got 4 roses, 6 carnations, that's 10, and 8 tulips. So that is 18. So we got 18 total objects, and we're trying to determine how many combinations using those 18 can we come up with for choices. And there's actually quite a few. So again, if I were using this in factorial, then this would become 18 factorial over 18 minus 4 factorial times 4 factorial. And you can calculate it that way. However, what we're going to do is we're going to go to the calculator, and there is a combinatory function, and that would be written as 18c for combinations 4. Or we may see it written like this, c 18, 4. Let's move to the calculator. We'll do a quick calculation. I'm not going to do the factorial. I did those in 2 previous videos. We're just going to use the combinatory function on our calculator. All right, we're talking about combinations where order is not important, and we were told that we had 18 flowers, 18 objects, and we're trying to figure out how many different combinations of those could be made if we're just going to come up with 4 choices. So 18 and 4. So I'm going to go to the math, hit math. I'm going over here to probability, and here I see option 3 is NCR, N total number of objects, R being the ones that are going to be chosen. So we're going to choose option 3, and we had 18 total flowers. I think it was 4 roses, 6 carnations, 8 tulips. We're going to have 4 flowers that are chosen, and how many different combinations could occur when we have 18 to choose from, but we're only going to choose combinations of 4. Are you ready? Hit enter. 3,060. Wow, a lot of different ways. That's pretty cool. A lot of combinations. Order is not important.